Hello, and welcome back to the Galactic Library. Tonight, my sleepy friends, let us gather our thoughts and let them drift away from the world you know. We are preparing for a long journey, a voyage in our minds past the familiar comforting glow of our own blue and white world. Let the sounds of your room fade, let the weight of the day dissolve. We are floating now, up and away, past the orbit of our silver moon, past the silent, tumbling graveyard of the asteroid belt. We are setting a course for a small, flickering point of light in the endless black, a pinprick of rust red, a tiny spark of ancient fire. For all of our history, it has haunted us. We have stared up at it from our earliest campfires, and we have given it names of power and dread. We called it Ares, the god of war, of sudden, brutal conflict. We called it Mangala, the auspicious, the fiery. We called it Mars. It was a portent of strife, a symbol of barren, cold, and sudden death. It hung in our velvet skies as a warning. But as our minds grew, as our curiosity became a tool, our vision of it changed. We turned our first crude glass lenses toward it, and in our profound loneliness, we imagined life. We saw, or desperately willed ourselves to see, a network of great canals. We imagined them as the grand irrigation projects of a dying, desperate civilization, etching a planet with their fading hope. We wrote stories of ancient, wise Martians, of beautiful, red-skinned princesses in crumbling, windswept cities. We dreamt of invaders, of powerful tripods and heat rays, a reflection of our own fears of conquest. Mars became a mirror, a vast, red, dusty canvas for our grandest hopes, our deepest terrors, and our aching cosmic solitude. We did not want to be the only thinking beings in this vast, silent, and impossibly large universe. Then our machines arrived. They were not grand ships of conquerors. They were tiny wheeled emissaries of aluminum, silicon, and plutonium. They fell through the thin pink sky and landed in clouds of ochre dust. And the images they sent back to us, across 100 million miles of void, were stark, magnificent, and utterly heartbreaking. They showed us no canals, no princesses, no cities. They showed us a tomb. They showed us a world that had perhaps once been like our own, a world with the unmistakable winding scars of dry riverbeds. They showed us vast, sprawling deltas where great rivers had once met ancient oceans. They found minerals, tiny spheres of hematite, and beds of gypsum that could only have been formed in the presence of vast flowing liquid water. It was a planet that had lived, and a planet that had died. Its atmosphere had been stripped away by a relentless solar wind, its protective magnetic field long dead. Its water was either gone, blasted into space, or locked in frozen tombs miles deep beneath the poles and buried in the permafrost. The air that remained was a ghost, a whisper, 99% carbon dioxide, so thin that the sun's weak warmth could not be held. The surface was a sterile, frozen desert, a landscape of endless, shifting, rusty dust. It was bathed in a constant, deadly rain of ultraviolet radiation, and its very soil was poisoned with a chemical called perchlorate, a salt that is deeply, fundamentally hostile to the chemistry of life. It was, by every definition we had, a dead world. To conquer such a place seemed a fool's errand. To wage war against an entire planet's geology, against its very physics, was a form of madness. The spirit of Ares was too strong, too final. And so, humanity, after a long and sober pause, conceived of a different, more patient, more audacious approach. Not conquest, but cultivation. Not war, but gardening. This is the story of that grand, slow, and perhaps loneliest of all human endeavors. This is the story of a project that would span 1,000 years, a project that would consume the resources of nations and the lifetimes of generations. This is the story of a new kind of human being, born for a singular purpose. This is the story of the gardener of Mars. Tonight, let us settle in. Let the sounds of your world, the blue world, fade into a distant hum. Let us journey together to the red planet. Let us walk with the first and the last of these patient custodians, and let us watch over the span of centuries as they undertake the greatest act of creation our species has ever dared to attempt, the resurrection of a world. The canvas of dust, understanding the red tomb. Before a gardener can even dream of planting a seed, they must first walk the field. They must feel the soil, its texture, its grit. They must know the wind, the sun, the frost. They must learn the land's every secret, its every cruelty, its every hidden promise. For humanity, this process of understanding Mars took more than a century. It was an education written in the language of radio signals, relayed across the solar system by our robotic children. We called them Sojourner, a tiny six-wheeled pioneer, the size of a microwave oven, cautiously sniffing the rocks of Ares Vallis. We called them Spirit and Opportunity, the twin Mars exploration rovers, tough-as-nails robotic geologists who were designed for 90 days of work and who, in Opportunity's case, stubbornly refused to die for 15 years. They sent us postcards from a place called Meridiani Planum, images of a vast, flat plain that once was the bottom of a salty, acidic sea.
They found blueberries, tiny, iron-rich spheres that had precipitated from ancient water. They were the first to truly show us the evidence of a wet and perhaps living past. Then came Curiosity, a nuclear-powered laboratory the size of a small car. It landed with breathtaking precision in Gale Crater, a 96-mile-wide bowl with a 3-mile-high mountain of layered sediment at its center, Mount Sharp. Curiosity was our nose, our tongue. It drilled into the rock, it vaporized soil with a laser, and it tasted the chemistry of ancient Mars. It found mudstone, clear evidence of a placid freshwater lake that could have existed for millions of years. It found organic molecules, the complex carbon building blocks of life itself, locked within the ancient rock. It also confirmed the profound, deadly nature of the surface, the constant scouring radiation, the thin air, the toxic perchlorates that laced the dust. And finally, Perseverance arrived, landing in Jezero Crater, the bed of another, even more ancient lake and river delta. It came not just to study, but to collect. It began drilling and sealing a cache of the most promising rock samples, a message in a bottle left on the shores of a dead world, waiting for a future mission to retrieve and bring home to Earth. These machines, these brave mechanical proxies, painted a portrait of our neighbor. And it was a portrait of brutal, magnificent desolation. Imagine for a moment you are standing on that surface. You are on the floor of Gale Crater next to Curiosity. The first thing you notice is the sky. It is not blue. It is a pale, sickly, butterscotch pink, a thin, dusty salmon color. The sun is a small, sharp white disk, its light feeling weak and distant, like the light of a late winter afternoon, but without any of the warmth. The second thing you notice is the silence. It is not the silence of a quiet forest, which is full of the tiny, invisible sounds of life. It is not the silence of a desert, which has the whisper of wind and the scurrying of hidden things. This is a profound geological silence. It is the sound of atoms slowly cooling. It is the sound of nothing happening and of nothing having happened for 1 billion years. The air is so thin, just 0.6% of Earth's pressure, the equivalent of being 100,000 feet up in our own atmosphere, that it cannot carry sound effectively. A shout would be a thin, reedy whisper. The third thing you notice is the cold. It is not just a sensation, it is an active, crushing presence. The average global temperature is -80 degrees Fahrenheit, a cold that will freeze carbon dioxide gas straight from the air into a fine, glittering snow of dry ice. Even on a warm summer day at the equator, the temperature might climb to a balmy 70 degrees at your feet, but at your head, it would still be 30 degrees below zero. This is a cold that shatters steel and makes rubber as brittle as glass. And the landscape. Oh, the landscape. It is a monument to a scale that dwarfs our human imagination. From your place in the crater, you can look up and know that elsewhere on this planet, there is a volcano named Olympus Mons, a shield volcano so vast it would cover the entire nation of France, its peak rising almost 70,000 feet into the thin air, 3 times the height of Mount Everest. Its caldera, the crater at its summit, is 50 miles wide. You could place the entire city of London inside it. Far to the east, there is a scar, a system of chasms called Valles Marineris. It is not a canyon. It is a tectonic rift that, if placed on Earth, would stretch from New York City to Los Angeles. It is 2,500 miles long, 120 miles wide, and in places 4 miles deep. It is a wound on the face of the planet, a place so deep that the air pressure at the bottom is noticeably higher than on the plains above. This was the canvas. It was a world of non-stop lethal radiation, a world with no ozone layer, no magnetic field, a world where the soil itself was a poison. And yet, our rovers, in their patient, multi-decade survey, found the one thing that mattered. They found the water. It was not flowing, but it was there. It was locked in the polar ice caps, Planum Borum in the north and Planum Australe in the south. These were not small patches of ice. They were continent-sized sheets, miles thick. The northern cap in particular was a colossal reservoir of pure, frozen water, larger in volume than the ice sheet of Greenland. And beneath the dust, almost everywhere, even near the equator, our orbiters and landers detected permafrost, a solid, rocky ice just inches beneath the regolith. The water was there. The planet was not empty. It was a seed frozen in time. It was a tomb, yes, but it was a tomb that held the frozen ghost of an ocean. And a gardener can work with a seed. The first footsteps, surviving the red world. After the machines, we sent people. The first human missions to Mars were the single greatest and most dangerous undertakings in the history of exploration, making the Apollo missions look like a weekend trip. These were not missions of colonization. They were not even missions of science in the truest sense. They were missions of survival. They were an attempt to answer a single brutal question. Can a fragile, water-filled, air-breathing human being, evolved for the warm, wet, shielded paradise of Earth, exist for even a moment in the most hostile environment in the solar system? The journey itself was a trial, a 6 to 9 month voyage through the vacuum of space, a cramped existence in a metal can, constantly bombarded by cosmic rays. The crews would arrive at Mars pale, their muscles atrophied from months of weightlessness, their bodies riddled with more radiation than a nuclear plant worker would see in a lifetime. And then, the landing. The 7 minutes of terror.
The atmosphere was too thin for parachutes to be truly effective, but just thick enough to burn a spacecraft to cinders if it entered at the wrong angle. The first missions used a terrifying, brilliant combination of heat shields, supersonic parachutes, and, in the final moments, the brute force of retro-rockets, landing a small, cramped habitat on pillars of fire. The first human outpost was not a shining city on a hill. It was a bunker. It was a collection of HAB modules, landed in a cluster, and then, with agonizing slowness, buried by robotic bulldozers under 6 feet of red, sterile regolith. This was the only way to survive. The Martian surface was a radiation bath. To live there, you had to live under it. The first explorers were, in essence, the loneliest people in history. They were the first humans to look up at the pink sky and see Earth not as a world, not as a blue and white marble, but as a bright, bluish-white star, indistinguishable from the others. A star that held every other human, every memory, every ocean, every forest, every war, and every love. They were separated from their home by a gap so vast that a radio message traveling at the speed of light took 20 minutes to cross, one way. You could not have a conversation. You could not call for help. You could only send a message, "Houston, we have a problem." And then, in the crushing, profound silence of your buried metal room, you would have to wait. You would wait 40 minutes for a reply. 40 minutes to know if your loved ones were even aware that you were dying. The job of these first crews was simple. Don't die. And learn. They drilled the first deep ice cores, pulling up cylinders of ancient frozen water. They were the first to set up MOXIE units, Mars Oxygen In Situ Resource Utilization, experiments that proved you could suck in the 99% CO2 atmosphere and through electrolysis crack it into breathable oxygen and carbon monoxide. And they were the first true gardeners. Their gardens were not fields. They were tiny, glowing vertical racks inside the habitat. Hydroponics and aeroponics. They grew the first food in Martian soil. They had to, because you could not ship a planet's worth of food. They took the toxic perchlorate-laced regolith and through a complex process of washing it, flushing it with melted permafrost water, they slowly, painfully cleaned a few precious pounds of it. Imagine the triumph of that first harvest. A single, small, slightly too pale red radish. The astronaut who pulled it from the damp red soil reported with a tremor in her voice that it tasted of chemicals, of metal, and of absolute, definitive victory. Many of these early missions failed. Some were lost in the long transit, victims of a solar flare or a simple catastrophic equipment failure. Some landed only to succumb to the dust. The Martian dust, fine as talcum powder, was abrasive, electrostatically charged, and toxic. It clogged filters, it ground down seals and gaskets, it worked its way into everything. It was a patient, relentless foe. Some missions were lost to the simple, crushing psychological weight of existing in a tiny, buried box 100 million miles from everything, in a place that wanted, in every conceivable way, for you to die. But enough succeeded. They left a legacy. They built the first base camp at the foot of the highlands, near the great ice-rich basin of Hellas Planitia. They proved that humans, those fragile, complicated bags of chemistry, could endure. They were the plowmen, breaking the first, hard, frozen, poisoned soil. And they prepared the way. They laid the groundwork for the ones who would come, not just to visit, but to stay. The ones who would be given the most audacious, most patient, most arrogant title in human history, the head gardener of Mars. The grand blueprint, forging a new greenhouse. The task, when laid out in engineering documents and climate models, was, in a word, godlike. It was not to build a city or a railroad or a nation. It was to build a biosphere. It was to take a planet that had been geologically and biologically dead for 3 billion years and force it to live. The problem was singular, and it was elegant in its simplicity. Mars was too cold because its atmosphere was too thin. A thin atmosphere cannot hold heat. It has no thermal blanket, no greenhouse effect. The weak sunlight that hits the planet simply radiates back out into space. The solution, therefore, was equally simple. Thicken the atmosphere. If you could add gas, any gas, to the atmosphere, you would start to trap heat. The planet would warm. If it warmed enough, just a few degrees, the vast frozen deposits of carbon dioxide at the South Pole would begin to sublimate, turning directly from solid dry ice into CO2 gas. This would thicken the atmosphere even more, which would trap more heat, which would warm the planet further, which would release more CO2 from the pole. It was a runaway positive feedback loop, a forced greenhouse. This was the entire theory. The plan, conceived over decades by the brightest, maddest, and most patient minds on Earth, was broken into 3 phases, each expected to take centuries. This was not a project for a single government or a single generation. It was a project for a dynasty. The Gardener of Mars became a formal title, a role passed down from master to apprentice, a 1,000-year commitment. The first gardener was not a farmer. She was a planetary engineer. Her name was Dr. Ilera Vance. Her partner and the true workhorse of the project was an artificial intelligence named Ares, a portmanteau of Ares and Iris, the god of war and the messenger of the gods.
Ares would run the calculations, monitor the factories, and manage the incomprehensible energy budgets. Ilara's job was to be its conscience, its human failsafe, and the one to give the go commands. The first phase of the plan was the brute force phase. The goal? Pump the Martian atmosphere full of the most potent greenhouse gases imaginable. On Earth, humanity had fought a desperate, century-long battle to reduce its carbon and methane emissions. On Mars, they would build the greatest, most obscenely polluting factories in the history of the solar system. And they would do it on purpose. Dozens of automated ships, great robotic freighters, were launched from Earth and the Moon on one-way trips. They were not designed to land. They were designed to crash, by design, onto the flat, desolate plains of Amazonas Planitia. And from their colossal, tangled wreckage, they unfolded. Like metallic origami, they self-assembled into vast, sprawling complexes. They were powered by small, safe, next-generation nuclear reactors. Their one and only job was to consume the Martian world. They were, in essence, giant chemical processors. They breathed in the thin CO2 atmosphere. They ate the red regolith, mining it for fluorine, chlorine, and carbon. And they exhaled. They pumped out in truly monumental quantities super greenhouse gases, perfluorocarbons, PFCs, chlorofluorocarbons, sulfur hexafluoride. These are compounds that on Earth were a nightmare. A single molecule of sulfur hexafluoride is over 23,000 times more effective at trapping heat than a molecule of CO2. On Earth, they were a catastrophe. On Mars, they were the breath of life. While these automated factories on the ground chugged away, relentlessly poisoning the sky to save it, a second, even more audacious part of the plan was unfolding in the blackness of space. A fleet of construction ships, tended by human engineers at the new permanent base on Mars's moon Phobos, began assembling a truly colossal structure. They built it at the Mars-Sun Lagrange Point 1, a stable gravitational pocket about 1 million miles upstream from the planet. It was a soletta, an orbital mirror. It was a vast, impossibly thin sheet of reflective film, thousands of kilometers in diameter, held in its gossamer-thin shape by a spiderweb of magnetic engines and computational thrust. It was a second, artificial sun. Its purpose was not to light the whole planet. That was impossible. Its purpose was to focus. Like a child using a magnifying glass to burn a leaf, the soletta would gather the sunlight that would have otherwise missed Mars and focus it into a single, precise, brilliant beam of concentrated energy, a scalpel of pure light. The factories were built. The soletta was in place. Ilara Vance, now a middle-aged woman who had spent half her life on the Red Planet, stood with her team in the command center on Phobos. Before her, 2 screens. One showed the atmospheric chemistry models from Eris. The other showed a live feed of the planet, a great rusty red orb hanging in the void. She took a breath, and she gave the command. Forcing the thaw, the geyser and the comets. The command, sent by laser, crossed the million-mile gap to the soletta. The great gossamer mirror, thousands of square kilometers of shimmering film, slowly, carefully adjusted its orientation. Its focal point shifted. The beam of concentrated sunlight, a column of energy now brighter than anything Mars had seen in 4 billion years, lanced across the vacuum of space, and it touched the planet. Its target was not a city. It was not a mountain. It was the South Pole, Planum Australe. The gardeners had chosen the South Pole for a very specific reason. The northern pole, Planum Borum, was a vast cap of frozen water, but the South Pole was different. It was a colossal, miles-thick, layered deposit of frozen carbon dioxide, dry ice. It was the planet's missing atmosphere, frozen solid onto the rock. When the soletta's beam hit the ice, the effect was immediate and violent. The pole began to steam, not with water, but with carbon dioxide. A vast white plume, visible from orbit, rose from the ice cap, a geyser of atmosphere itself. The ice, which had been stable for an eon, began to sublime, turning directly from solid to gas, bypassing the liquid stage entirely. The soletta's beam did not stay still. The Eris AI executing Ilara's command steered it in a slow, precise painting motion. It scrubbed the ice cap with light, vaporizing millions of tons of CO2 every single hour. The effect on the planet was profound. The barometric pressure on Mars, which had hovered for all of history at a deadly low 6 millibars, began to climb. It went to 10, to 30, to 100 millibars. This was not yet breathable. It was not even close, but it was substance. For the first time, the air had weight. As the air thickened with this new CO2, the super greenhouse gases being pumped out by the factories on the equator had something to work with. They began to trap the sun's heat with terrifying efficiency. The average global temperature, which had been a deadly -80 Fahrenheit, began to creep upwards. -70, -60. The planet, shocked by this sudden input of heat and air, began to make its own weather. For the first time in an eon, winds picked up. Not the thin, wispy breezes of the old Mars, but true, powerful, planet-spanning gales, carrying the new, thicker air around the globe.
Great dust storms, far more powerful and destructive than any our rovers had seen, now raged for months on end, kicked up by an atmosphere that had actual substance. The demon dust devils of old Mars were replaced by continent-sized cyclones of red powder. While the soletta worked on the pole and the factories worked on the equator, the third most violent part of Phase 1 began: the Asteroid Express. Humanity's long-range sensors had been tracking asteroids and comets in the outer solar system for decades. Now mass drivers, giant electromagnetic cannons built on Mars's 2 tiny captured asteroid moons, Phobos and Deimos, began their work. They were not firing missiles, they were firing momentum. They were nudging the trajectories of carefully selected objects. They were aiming for ammonia-rich comets from the Kuiper Belt and ice-rich asteroids. They were sent on careful, precise, multi-year trajectories to intercept Mars. Each impact was a cataclysm, a flash of light brighter than the sun, visible to the naked eye from Earth. A monumental, ground-shaking explosion that delivered thousands of megatons of raw kinetic energy. The first colonists, huddled in their buried bunkers, lived on a world that was being actively, constantly, violently bombarded from space and poisoned from the ground. They were tilling the soil with explosions. But these comets were not just for heat. They were delivering their cargo. They vaporized on impact, and their contents were blasted into the new, thickening atmosphere. They delivered thousands of tons of water vapor. But even more importantly, they delivered nitrogen. Nitrogen is the key. You cannot have a stable Earth-like atmosphere with just CO2 and oxygen. You need a buffer gas, an inert gas to add mass and pressure to prevent a pure oxygen atmosphere from becoming a global flammable inferno. Nitrogen is 78% of Earth's air. Mars had almost none. The comets, rich in frozen ammonia, or NH3, were the only way to get it. This was the tilling of the planetary soil. It was violent, chaotic, and terrifying. Ilara Vance, the first gardener, lived her entire life on Mars. She died of old age in the Phobos Command Center, her body long and thin from a life in low gravity. She never set foot on a green field. She never felt rain. She never breathed the air. Her entire life's work was simply to warm a rock, to raise the pressure, and to deliver the nitrogen. Her body was interred in a small, shielded mausoleum overlooking the vast, steaming, now diminished plains of the South Pole. She died, having only completed the first brutal chapter. The title of head gardener passed to her successor, who would be tasked with the next, even slower step, planting the first seed. The microbial pioneers, the first green-black stain. For the first 80 years of the terraforming project, Mars was a warmer, cloudier, and far more violent version of its old dead self. The air pressure was now high enough, approaching 150 millibars, or 15% of Earth's, that liquid water could exist, at least in the deepest basins. The air, however, was a toxic, unbreathable soup of 90% carbon dioxide, laced with PFCs, ammonia, and sulfur compounds. The temperature at the equator could, on a perfect summer day, now reach a balmy, muddy 50 degrees Fahrenheit. But it was not life. The second head gardener, a man named Kenji Tanaka, was not an engineer. He was a geneticist, a biologist of the extreme. His garden was not a field, it was a laboratory. His seeds were not for plants, but for microbes. You cannot plant an oak tree on Mars. You cannot plant grass or roses or wheat. The soil is still a chemical poison, laced with perchlorates. The air is unbreathable. The new water that was beginning to form in puddles and briny ponds was a toxic, acidic, chemical-rich sludge. You must start at the beginning. You must follow the blueprint of our own planet. You must send in the pioneers, the ones who make the soil, the ones who make the oxygen. For decades, on Earth and the Moon, genetic engineers had been working in secure bioforge labs. They took the hardiest life forms our world had ever produced, the extremophiles, and they made them harder. They took cyanobacteria, the ancient blue-green algae that were responsible for Earth's own great oxygenation event 2 billion years ago. These tiny single-celled organisms were the ones that first polluted Earth's early atmosphere with a deadly, corrosive gas, oxygen. The Martian strain was a marvel of engineering. It was modified to thrive in high CO2, low light, low temperature conditions. Crucially, it was given a set of new genes that allowed it to metabolize the perchlorates in the soil. It would literally eat the poison and break it down into harmless salts. It was also given genes to fix the nitrogen that had been delivered by the comets, pulling it from the air and turning it into nitrates, the fertilizer of life. They also took lichens. Lichens are not a single organism, but an incredible symbiotic partnership of a fungus and an algae. They are the first life to colonize bare, sterile rock on Earth. They are the masters of patience. The fungus part of the organism secretes powerful acids that dissolve stone, pulling out the minerals. The algae part photosynthesizes. When the lichen dies, its body, mixed with the broken-down rock, creates the first thin, precious, priceless film of organic soil.
The Martian lichens were engineered to be hyper-aggressive, to be black-green, to absorb as much of the weak sunlight as possible, to spread fast, and to withstand the still harsh ultraviolet light that scourged the surface. Kenji's job was to plant these. He and his team loaded great pressurized, heated rovers, seeder vehicles, with vast, temperature-controlled vats of a dark, bubbling, foul-smelling microbial slurry. They drove out from the main base at Hellas Planitia, the lowest, warmest, and now dampest point on the planet, and they began to spray. They sprayed the slurry over the rocks. They sprayed it onto the dust. They released payloads of it by drone into the first briny seasonal ponds that were beginning to form in the deepest craters. It seemed like a fool's errand. It was like pouring soup onto a desert the size of a planet. For the first few years, nothing happened. The scale of the planet was too vast, the microbes too small. The project was mocked, Kenji's mud. And then, the first report came in from a survey satellite. A patch of ground near the equator, in a sheltered valley where a small seasonal stream of brine was flowing, had changed color. It was no longer the familiar rusty red. It was a dark, damp, sickly greenish black. The lichens had taken hold. The gardeners accelerated the program. They built fully automated seeder drones, robotic aircraft that could fly in the new, thicker air, scattering the microbial packages across the globe. They focused on the equatorial regions, the muddy zones, where the permafrost was beginning to melt, creating vast, chaotic, saturated bogs. And Mars began to change. From orbit, it was a creeping, mottled darkness, a stain of life spreading from the equator and the deep valleys. The process was agonizingly slow. A generation passed. Kenji Tanaka grew old, his hands and arms permanently stained by the dark living cultures he tended. He passed the title of gardener to his apprentice. The work continued. The lichens ate the rock. The cyanobacteria bloomed in the muddy, shallow, seasonal seas. And as they did, they began their sacred chemical work. They consumed the carbon dioxide that filled the air, and as a waste product, a tiny, insignificant cumulative puff of gas, they released oxygen. It was the first free oxygen Mars had seen in billions of years. At first, it was a trifle, less than 0.1%. It was barely detectable, and it didn't stay in the atmosphere. This, the gardeners knew, was the next great hurdle. The Great Rusting and the Solar Storm. The new free oxygen that the cyanobacteria were producing was a miracle, but it was a fugitive. Oxygen is one of the most violently reactive elements in the universe. It wants to bind with other things. And on Mars, it was surrounded by a planet's worth of things to bind with. The surface of Mars is red for a reason. It is covered in iron oxide, rust. But this was an old, ancient rust. The new free oxygen being pumped out by the microbes began a new age of oxidation. This was the Great Rusting. As the oxygen levels in the air tried to climb, the planet itself fought back. The oxygen combined with the iron-rich dust, rusting the planet on a new molecular level. The surface, which was already red, burned a deeper, more vibrant, almost violent shade of crimson. The new briny ponds and shallow seas, which were a sludgy, muddy gray, turned a deep, brownish red as the iron dissolved in the water oxidized and precipitated out, falling to the bottom as a thick layer of rust-colored sediment. The gardeners were not discouraged. This was the plan. This was a necessary and agonizingly long phase. The first wave of life was not for breathing. It was a generation of life born to die. Its sole purpose, to prime the pump. It had to saturate the regolith with rust. It had to bind with all the free iron in the soil and water. Only then, once the rock and water could hold no more oxygen, would it finally be able to accumulate in the air. This process was expected to take 200 years. The gardeners settled in for the long haul. The great black-green patches of microbes spread, and the planet slowly, deeply rusted. And then, the disaster happened. The sun, as it had always done, and as it would always do, entered a new, violent cycle. It unleashed a massive solar flare, a coronal mass ejection. A vast, billion-ton cloud of magnetized plasma, a wave of high-energy protons, was blasted out from the sun's surface at millions of miles per hour. On Earth, the planet's powerful magnetosphere, the magnetic field, would have harmlessly absorbed it. The particles funneled to the poles, creating beautiful, shimmering curtains of light. Mars had no such shield. The wave of high-energy particles washed over the red planet with the force of 1,000 nuclear bombs. The radiation spike on the surface was catastrophic. The surface-dwelling microbes, the precious lichens and cyanobacteria that had taken 50 years of patient cultivation to spread, were sterilized. The radiation shred their simple DNA. The great black-green patches that had been a badge of victory were bleached in a matter of hours, back to a sterile, dead red. The atmospheric oxygen level, which had just begun its slow, painful, imperceptible climb, plummeted back to zero.
A century of work, undone in a single 48-hour solar event. The third head gardener, a woman named Shivan Nimura, was the first of her line to be born on Mars. Her bones were longer and thinner than an Earth human's. Her body, adapted to 38% gravity, was frail and tall. Her eyes were accustomed to the dim pink light of the buried habitats. She had tended this fledgling garden her entire life. She had watched the black stain spread, and now it was gone. Her team was broken. The psychological blow was almost too much to bear. Many wanted to give up, to retreat to the sealed, buried domes forever, to accept that Mars was a tomb and that life could only ever exist there behind a shield of rock. To live on Mars, they said, was impossible. The sun would never allow it. But Shivan, a descendant of a long line of patient, stubborn farmers from a green, rainy island on that distant blue world, refused. She stood before her council, her tall, frail form trembling with a cold fury. The problem, she declared, was not the seed. The seed was strong. The problem was not the soil. The soil could be tamed. The problem was the sky. The garden had no roof. It was time, she declared, to build one. And it was time to unlock the floods. Unlocking the floods. The coming of the water. The Great Warming, started by Lara Vance and her soletta, had worked. The atmosphere was thick with CO2 and nitrogen. The planet was, on average, now hovering just below the freezing point of water. But the vast majority of Mars's water, an amount of water equivalent to a global ocean 300 feet deep, was still locked away, frozen solid. The primary reservoir was the North Pole, Planum Boreum, and in countless glaciers and in a thick planet-wide layer of permafrost buried just beneath the dust, the soletta, the great orbital mirror, was still in place, still patiently warming the planet. Siobhan's team gave it a new target. For a century, it had been focused on the South Pole, releasing CO2. Now, it shifted its gaze. It focused its brilliant, concentrated beam of light on the North. The North Pole was different. It was not a cap of dry ice. It was a colossal, swirling, layered cap of pure, frozen water. Miles deep, thousands of miles across. The beam of focused sunlight, a scalpel of pure energy, began its new work. It did not sublimate this ice. It melted it. The first melt was slow, a trickle. But the gardeners, having learned from the Asteroid Express, did not just use light. They began a new campaign of targeted kinetic impacts. They were not using giant ammonia-rich comets anymore. They were using smaller, precision-guided rods from God, dense, heavy projectiles fired from orbit by the mass drivers on Phobos. They struck the edges of the ice cap, shattering the frozen miles-high cliffs. They used the brute force thermal energy of friction to turn ice into steam and water. And the great thaw began. At the edge of Planum Boreum, a new feature appeared on the Martian landscape. A lake. A vast, gray, slushy, churning body of liquid water. It grew. In a matter of months, it became a sea, and it began to flow. Mars's northern hemisphere is, on average, miles lower in elevation than its southern highlands. The Great Vastitas Borealis Basin is the single largest, flattest region on the planet. Geologists had known for centuries that it was the bottom of an ancient, long-dead ocean. Now the water was returning to it. It did not come as a gentle river. It came as a cataclysm. A wall of gray, icy water, churning with mud and carrying icebergs the size of office buildings. It scoured the ancient dry outflow channels, the Casse Valles, the Aris Valles, places that had been dry for an eon. The gardeners and their robotic drones watched from the safety of the highlands as the first true flood of the new Mars clawed its way south. The atmosphere, already thick with CO2, became saturated. The steam from the melting ice and the kinetic impacts rose, and then the first rain fell on Mars. It was not a clean, pure Earth rain. It was a filthy, acidic, chemical-rich drizzle. The water was briny, full of the perchlorates and salts it was washing from the soil, and thick with the red dust. It was a rain of liquid mud, but it was rain. In the domed cities, people wept. They ran to the thick quartz viewports and placed their hands on the glass. Siobhan Nimura, now an old woman, her body frail, ordered the outer airlock doors of her habitat unsealed. She stepped out, not into the thin, dry cold she had known her life, but into a thick, damp, frigid fog. She wore a heavy, heated parka. She held out her gloved hand and felt the first heavy, muddy drops of liquid fall from the sky. The new water changed everything. It flowed into the great impact craters, Hellas, Argier, Gale. It formed shallow, muddy, briny seas. The planet was no longer just red, it was a mottled planet of red, black, and a new, dull, metallic gray. The water accelerated the gardening. The cyanobacteria, which had been confined to small, protected ponds, now had oceans. They exploded in a planet-wide algae bloom. The lichens, loving the new constant moisture, raced across the rocks, and the oxygen levels began to rise again, this time with a vengeance. But Siobhan knew this was a false victory.
She knew, from the disaster that had broken her heart, that the solar winds were still blowing. The radiation was still intense. As fast as the algae produced oxygen, as fast as the water vapor entered the air, the sun was stripping it away. Her final act as head gardener, her last will and testament to the planet of her birth, was to approve the most expensive, most complex, most unbelievable engineering project humanity had ever or would ever attempt. She gave the order to build the shield. The problem was fundamental. It was the problem that had killed Mars in the first place. The planet was a living world without a pulse. The iron heart of the planet, its molten core, had cooled and frozen billions of years ago. And when it died, the planet's protective magnetic field, the invisible shield that deflects the solar wind, had died with it. Without a magnetosphere, the solar wind, that relentless, high-energy stream of charged particles from the sun, acts like a cosmic sandblaster. It hits the upper atmosphere and, molecule by molecule, it strips it away, blasting it into deep space. This was why Mars died. The gardeners, Shallan and her team, were now in a desperate, losing battle. They were pouring water and oxygen into a bucket that had a giant gaping hole in the bottom. The algae blooms and microbial mats were producing oxygen at a staggering rate, but the planet simply could not hold on to it. The solar wind was tearing it away faster than it could be made. The fourth head gardener, a quiet, brilliant engineer named David Sun, was not a biologist. He was a plasma physicist. His battlefield was not the ground, not the soil, not the water. His battlefield was the empty void of space, 1 million miles upstream of Mars, at the L1 Lagrange point. This was the project Siobhan had approved. The magnetic shield. The artificial magnetosphere. It was, in essence, a plan to build an artificial planet core. A fleet of automated construction drones, the largest ever assembled, spent 50 years at the L1 point. They were the spiders weaving a new web for the planet. They mined asteroids that were nudged into their path. They cannibalized the old, dead freighters and factory ships, and they built a single, colossal object. It was not a solid shield. You could not see it. It was a superconducting ring, a torus, a giant electromagnetic donut, dozens of miles in diameter. It was, by mass, the single largest object humanity had ever built. David Sun and his team, from their new, expanded control center on Phobos, sent the command. Nuclear reactors on board the shield itself, the size of small stars, spooled up. A massive, unimaginable electrical current was fed into the superconducting ring. A magnetic field blossomed in the vacuum of space. It was not a global field like Earth's. That would be impossible. It was a magnetic dipole, a precisely shaped, invisible bubble. It was a teardrop of pure force positioned perfectly between Mars and the Sun. The solar wind, which had for billions of years scoured the red planet, now hit this invisible wall. The charged particles, instead of hitting Mars, were funneled around the shield. They were redirected, like water flowing around a boulder in a stream. The planet Mars was, for the first time in 4 billion years, in the shadow of a protector. The effect was instantaneous. The atmospheric stripping, the leak in the bucket, stopped. And, for the first time, a new, beautiful phenomenon appeared in the Martian sky. As the charged particles of the solar wind were funneled around the planet by the new shield, they interacted with the now thick atmosphere at its edges. A faint, shimmering, green and purple aurora appeared. The Aurora Martis. The planet had an artificial heartbeat, and it was beautiful. Now the bucket was sealed. Now the real war for oxygen could begin. The oxygen levels in the atmosphere, which had struggled to reach even 1%, began to climb. 1%, 2%, 5%. The great rusting accelerated, a final planetary-scale chemical frenzy. But now the microbes were producing oxygen faster than the rock could absorb it. The oxygen levels climbed past 10%, past 15%. The sky, the beautiful, sickly, butterscotch pink sky of old Mars, was gone forever. As the air thickened, as the dust began to be washed out of the air by the constant muddy rain, a new phenomenon took over: Rayleigh scattering. The same physics that makes Earth's sky blue, scattering the shorter, blue wavelengths of light. On Mars, it wasn't quite blue. The air was still rich in CO2 and trace dust. The sky became a pale, hazy, breathtaking aquamarine, a gentle, alien turquoise. And the sunsets on old Mars, as our rovers had shown us, had been a faint, ethereal blue. Now, with the new, thick, dusty, wet atmosphere, they were a riot of color. They were splashes of deep violet, of burning orange, and of profound, deep purple. The sixth gardener, an old woman named Amina, did something no human had ever done. She walked out of her habitat high on the rim of Gale Crater, which was now filled with a gray, churning inland sea. She walked out not wearing a full pressure suit, but a simple insulated parka and a respirator mask, the kind a firefighter might wear. The pressure was high enough. The temperature, a chilly but survivable 40 degrees, was high enough. The air was still toxic, over 60% CO2, only 16% oxygen, but it was air.
It had substance. She stood on the ridge, breathing the filtered, compressed air from her mask, and she looked out over the new turquoise sky. She could hear the wind. For the first time, she could hear it with her own ears, not through a microphone. It was a thin, whistling, mournful sound, but it was wind. Her garden was almost ready. The soil had been eaten by lichens for 3 centuries. It had been washed by acidic rain. It had been rusted by free oxygen. It was no longer sterile, toxic dust. It was, finally, soil. Amina, the sixth gardener, bent down. She was wearing thick gloves. She scooped up a handful of the cold, damp, brick-red earth. She smiled. It was time to plant a tree. The Arboreal Initiative was the project the gardeners had dreamed of for 400 years. It was the transition from planetary engineering, from the brute force physics of solettas and magnetospheres, to actual, recognizable, living gardening. But again, the challenge was immense. You could not plant an earth oak. You could not plant a delicate maple. The soil, while no longer toxic, was still little more than damp, rusted rock powder. It had almost no organic matter. The air was breathable with a mask, but it was still 60% CO2. The winters were brutal, planet-wide deep freezes that would kill any unprotected temperate plant. The gardeners, now led by a new generation of botanists and ecologists, began their work in the most sheltered, most promising place on the planet, the bottom of Valles Marineris. 4 miles deep, the Grand Canyon of Mars was a world unto itself. The air pressure there was the highest on the planet, almost 30% of Earth's sea level pressure. The temperatures were mild,
the deep canyon floor protected from the worst of the new global winds. And for centuries, the muddy rains had washed sediments and minerals down into its depths. The first plants sent to this new alien Eden were not majestic. They were the toughest, hardiest, most stubborn forms of life Earth had to offer, made even tougher in the gene labs. They planted Siberian pines, genetically modified to withstand extreme cold and to thrive in a super-high CO2 environment. They planted vast, sprawling groves of a fast-growing bamboo analog, a plant designed for one purpose: to create a deep, binding, fibrous root network, to take the new loose soil and hold it, to prevent it from eroding in the rains. They planted Arctic willows, creeping mosses that could grow on bare, damp rock, and fields of hardy, coarse, sedge-like grasses. The first forest on Mars was a scraggly, tough, dark green patch at the bottom of a 4-mile deep canyon, tended by robotic drones and a handful of very patient, parka-clad humans. But it was a forest. For the first time on Mars, there was the sound of wind rustling through pine needles. For the first time, there was the smell of damp earth and resin. And with the trees came the next crucial step. Life is not just plants, it is a system. A garden needs its workers. A forest needs its unseen engineers. The gardeners began the introduction. They brought the first animals to Mars. Not deer or rabbits or birds, not yet. They brought insects. They brought genetically modified bees and moths, hardy pollinators designed to work in the thin air and cold. They brought beetles, mites, and springtails, the tiny decomposers. And most importantly, they brought legions. They brought trillions of Earth's most humble, most important, most transformative engineer, the earthworm. The worms cultivated in vats at the main habitat were released by the ton into the new damp soil of Valles Marineris, and they began their sacred silent work. They consumed the dead microbial mats. They ate the fallen pine needles. They processed the raw, mineral-rich regolith. They churned the soil. They aerated it, and in their guts they transformed it. They turned the sterile, chemical-rich mud into true, living, fertile, nitrogen-rich loam. The trees, fed by this new, living soil, thrived. The forests of Valles Marineris exploded. They began to climb, with agonizing slowness, up the canyon walls. The gardeners, emboldened, using the new, warmer, wetter global climate, began planting on the plains above. They seeded the vast, muddy flats of the northern basin, which were now a planet-circling marshland. They planted hardy grasses that sent down deep, deep roots, anchoring the landscape. The planet, which had gone from red to red and black, to red and gray, to red and green, now began to turn a deep, vibrant forest green. The ecosystem was taking off. The oxygen level, boosted by this new, complex, continental-scale wave of plant life, finally crossed the magic number, 20%. The CO2 levels, consumed by the voracious, fast-growing new forests, began to drop. 60%, 50%, 30%. After 500 years of continuous, agonizingly slow, multi-generational work, the air on Mars was breathable. The ninth head gardener, a man named Corwin, was a direct descendant of the project's first human explorers. His family had never known Earth. Mars was their home. He celebrated his 50th birthday by doing what his ancestors had only been able to dream of, what they had died to make possible. He stood on the rim of the Arger Basin, a vast, circular plain in the southern highlands that was now a shallow blue-green sea. He looked up at the pale turquoise-blue sky. He watched a cloud made of water drift by. And slowly, his hands trembling, he unclipped the seals on his respirator. He lowered it from his face. He took a breath. The air was thin, it was cold, and it tasted of dust and growing things, of pine and damp rock. It was the air of a high, 20,000-foot mountain summit on Earth. You would get tired quickly. You would be breathless, but it was air. It filled his lungs. It gave him life. He wept. The Great Migration began. On Earth, which had been watching the Mars project for centuries, a project that had unified the planet in a singular grand purpose and in many ways inspired it to begin healing its own climate, the news was a thunderclap. Mars was open. The ships began to arrive, not as tiny, cramped survival capsules, but as great starliners, vast spinning vessels carrying thousands of colonists at a time. They were not coming to be explorers, huddled in bunkers. They were coming to be immigrants, to build new lives, new cities, in a new world. The gardeners, their primary work of atmospheric creation now complete, transitioned into a new, permanent role. They were no longer planetary engineers. They were, at last, truly gardeners. Their job became to manage this new, fragile, artificial, beautiful world. The new Eden and the gardener's paradox. The Mars that greeted the new wave of immigrants was a world of breathtaking alien beauty. It was a world of low gravity, where a person could jump 3 times as high, where a fall that would break your legs on Earth was a gentle tumble. It was a world where a child could leap onto the roof of a house. The colonists, used to Earth's heavy, crushing pull, felt light, powerful, and graceful. It was a world of deep, profound, impossible colors. The ancient highlands, the parts that had not yet been planted, remained a stark, rusty, magnificent red. The vast northern ocean, which now filled the Vastitas Borealis basin, was not a deep, dark blue like Earth's. It was a shallow, reflective turquoise, its waters still rich with minerals, giving it a bright, milky, opalescent sheen. And the new forests, which now covered the continents, were a deep, dark, hardy green, the color of pine and moss. The new cities were built not as domes, but as open-air settlements. They were carved into the canyon walls of Valles Marinares, creating vertical cities of waterfalls and hanging gardens. They were nestled on the shores of the new northern ocean, cities of white and red rock. They were cities of tall, slender spires, elegant, impossibly thin towers that were possible only in the light gravity, reaching up into the pale blue sky. This was the new Eden, but it was an Eden with a secret. It was the most complex, most expensive, most profoundly artificial object ever created. It was a machine built of rock and water and air and life, and it needed its mechanics. This gave rise to the gardener's paradox. The head gardener, a title now held by a council rather than a single person, was in charge of the planet's life support systems, which was in effect the planet itself. The artificial magnetosphere at L1, the shield that kept the planet alive, needed constant maintenance, its reactors refueled, its systems monitored. The vast globe-spanning AI, now Planet Core, had to monitor the atmospheric blend. The ecosystem itself, which had been designed from the ground up, had no natural balance. It had not had millions of years of evolution to create one. It had to be managed. A new genetically modified insect brought in to pollinate a specific type of Martian tundra flower might prove too successful. Its population might explode, threatening the foundational pine forests. The Gardener Council would have to, after long debate, approve the release of a custom-engineered predatory wasp to bring it back in line. A new strain of algae in the northern ocean might bloom too quickly, fixing too much carbon, pulling the CO2 levels down too fast, and threatening to plunge the entire planet into a sudden, catastrophic cold snap. The gardeners would have to release a custom, precision virus to cull it. Mars was not a wilderness, it was a garden the size of a planet, requiring constant, vigilant, careful, omniscient tending. This created the first great philosophical divide in the new Martian society.
The preservationists, many of them descendants of the very first colonists, argued that some of Mars must be kept as it was. They pointed to Olympus Mons, the great volcano. It was so tall its peak still poked out of the new thick atmosphere. It was a sterile, red, frozen, magnificent monument to the old Mars. They argued that to plant trees on it, to let the new ocean lap at its base, would be a crime. It would be like painting over a masterpiece. The gardeners, on the other hand, argued that life was the ultimate imperative, that their sacred thousand-year duty was to spread life, to make the barren green, to fulfill the original promise. The debate raged for decades. In the new Martian parliament, laws were passed and repealed. In the end, as is often the case, a compromise was reached. Olympus Mons and a few other key landmarks, the heart of Valles Marineris, the landing site of Viking 1, were declared World Heritage Preserves. They would be protected by law, left untouched. They would remain sterile, red, and dead. They would be a museum of the world that was, a place where new Martians could go, in pressure suits, to stand in the profound silence and see their planet's history. The rest of Mars would be given over to life. The gardeners began the final phase, the diversification. The ecosystem was stable. Now it was time to make it rich. They introduced more complex animals, birds, engineered with larger lungs and wider wings to fly in the thinner air. Hardy, modified mountain goats, adapted to the red rock canyons. Fish for the new oceans. 1,000 species, all carefully curated, all genetically tweaked to fit into the artificial, managed ecosystem. The final head gardener, a man named Alien, was a descendant of the very first, Ilara Vance. He was a man of the 10th generation. His family had tended this planet for 1,000 years. His job was less about creation and more about listening. He would walk without a respirator, without even a parka on a warm day, through the great dark pine forests of the Tharsis region. He would breathe the cold, thin, oxygen-rich air and listen. He would listen to the wind, the cry of the new Martian eagles, the sound of the worms in the deep red soil. His garden was, at last, stable. The systems were becoming self-correcting. The new, managed wilderness was beginning to manage itself. The feedback loops were closing. The planet was, in a very real and tangible sense, alive. The gardener's paradox was solving itself. The ultimate, final, secret goal of the gardener was to become unnecessary. To plant a garden so well, so wisely, that it no longer needed a gardener. Alien stood on the shore of the northern ocean. The turquoise water lapped at a beach that was not of white sand, but of fine, red, iron-rich grains. He looked at the pale blue sky. He watched a flock of white, long-winged birds fly overhead. He felt the cold, crisp, living wind on his face. His work, the work of his family for 1,000 years, was done. The legacy of the Red Garden. Tonight, my sleepy friends, our long, century-spanning story comes to an end. But for the Martians, life was just beginning. Humanity was now a two-world species. The Martians, those born and raised in 0.38 gravity, were a new, distinct branch of humankind. They were, on average, a foot taller than their earthbound cousins. They were slender and pale, their bodies adapted to the thin air and the weaker, more distant sun. They were a people defined by the ethos of the gardeners, patient, long-term thinkers, resilient, and deeply, almost religiously connected to the fragile, beautiful, managed world they inhabited. And what of Earth? In the 1,000 years it took to bring Mars to life, Earth had watched. It had poured its resources, its genius, and its hope into that red point of light. Inspired by the unity and the sheer impossible will of the Mars project, Earth had begun its own great work of repair. The gardeners of Earth, using techniques and, more importantly, a philosophy learned on Mars, had cleaned their own skies. They had healed their own oceans. They had regreened their own deserts. The resurrection of the red planet had, in the end, been the blueprint for the salvation of the blue one. And so, let us leave this new, vibrant green and red world. Let us imagine ourselves, one last time, walking with Alien, the last gardener. We are walking at sunset. The sky above is a deep, impossible violet, and the sun is setting behind the great, slender red rock spires of the new city of Eris. The air is cold, and it smells of pine resin and the distant, salty tang of the northern ocean. We can hear the wind in the trees, a sound that, for an eon, did not exist here. We can hear the faint cry of a night bird. We look up into the deep twilight, past the two fast-moving moons of Phobos and Deimos, which now glitter with the lights of human settlements. And we see a star, brighter than any other, a brilliant, piercing, blue-white point of light. It is the evening star, the most beautiful jewel in the Martian sky. We know it by its ancient name. We call it Earth. It is a garden too. And from here, from this new living world, it looks healthy. It looks bright. It looks full of life. The gardener's work is truly complete. Thank you for joining me tonight at the Galactic Library. I hope this story of Mars has given you a sense of peace, of scale, and of the profound, defiant patience of creation. If you enjoyed our long journey together, please consider liking this video and subscribing to the channel for more stories from the quiet corners of the cosmos. Until next time, sleep well.